Welcome everyone to the Mold X3D webinar series. My name is Alex Baker from the Mold X3D North America office here in Farmington Hills, Michigan. Our agenda today is as follows. We're going to start by defining what is sprue pressure. Then we're going to jump into some pressure discrepancies in simulation. And finally, how do we fix those discrepancies? I think in general, the accuracy of pressure prediction from simulation is always a big question mark, especially when you're trying to correlate from the real molding process to the simulation world. And this will serve as a really nice guide for you as to, what is actually wrong, first of all, and um, how can we, first of all, diagnose what's wrong, and second of all, how can we actually fix that moving forward? All right, so first of all, we'll define what is sprue pressure. So sprue pressure is the pressure reading from the melt entrance. So whenever you define a melt entrance on your model, that is where the pressure reading is measured from. Anything above the melt entrance, if you do have anything above the melt entrance, will not be included in the pressure reading. In general, the filling stage is a velocity controlled condition, meaning that we're trying to hold a constant flow rate, and the pressure will need to increase to maintain that constant flow rate as the resistance to flow increases. As we get further and further away from the melt entrance, that's going to cause flow restriction, and in order to maintain that constant flow rate, we have to increase our pressure as a response. And as I mentioned before, only the objects after the melt entrance will be considered in this sort of pressure prediction. So we need to make sure that we have our entire system modeled in, not necessarily just an approximated model, especially when we're trying to correlate the pressure between simulation and reality. We need to consider all sources of pressure drop, all sources of flow restriction, which would include a hot runner. It would include a nozzle, as I'm going to be going through as we kind of run through all the different sources of discrepancy. So it's very important that all significant sources of pressure loss should be considered in the simulation. All right, so what does a typical sprue pressure curve look like? We really have three main sections. The first of which is going to be your pressure loss in the feed system. That's going to be usually a pretty quick pressure loss. There's some flow compression as you go down through your gate. There's going to be, especially in the case of a hot runner system, there's going to be a lot of quick pressure drop, like what we see right here. That pressure drop will happen almost instantaneously because there's no amount of time needed to actually flow the material through that object. The object is already filled. It's just going to, the flow past that object is going to create a flow restriction. So it almost just elevates or shifts the sprue pressure curve upwards in that regards.